Hello everyone, my name is Aryan Mehta and I'm currently a final year student in Delhi Technological University pursuing engineering. I have my other fellow partners, Jaskaran and Kanish Dayal, and we were supervised by our professor, Dr. Seva Susan, who had a huge contribution in this. Uh, I'm here to present on the topic Unsupervised Sentiment Analysis Approach on IMDb reviews using fuzzy aggregation approach. So, an introduction about our topic. What is sentiment analysis? Sentiment analysis is a huge part of NLP. So it takes a sentence or a text and then it tries to find out the feeling or the gist behind the sentence. So it could be either positive, negative, or neutral. There are two ways to find the sentiments. One is unsupervised methods and another is supervised methods. But we chose to go the unsupervised way. This is because unsupervised methods have an advantage over supervised ones in case of sentiment analysis. This is because the dataset which we get in sentiment analysis is usually not labeled. To give you an example, a dataset could be reviews of a product or a movie, or it could be comments in a reel, or it could be thoughts about certain companies. So all these are not labeled; they are just comments and or sentences provided by people. The three models which we chose to go about it were Affin, TextBlock, and Veda. These three are very famous in sentiment analysis, and these three are unsupervised methods. So our main purpose of this was to get these straight to for fuzzy aggregation and integrating them to find out a new score or polarity, uh, so that we can increase our accuracy of sentiment analysis. So, a quick introduction about the models. The first model was Affin. So, Affin is a lexicon based approach for sentiment analysis. What it means is that it takes a sentence or a text, it breaks it out into words. Now, each word has an associated weight with it. In Affin, the weight of each word is between -5 to +5. Then we find the aggregated sum of the weights for a sentence. Now, this aggregated weight sum is used for sentiment analysis. We keep some threshold. If the score is above the threshold, that means it is a positive sentiment. If it is below the threshold, it is a negative sentiment. If it is equal, it can be considered as neutral too. So AFN supports more than 3,300 words in English language, and it is continuously upgrading and updating them. It also has multi-language support. Uh, so the next model is TextBlog. So TextBlog is a very famous Python library which is used in NLP tasks and sentiment analysis. So TextBlog is also unsupervised and a lexicon-based model. It has two parts, polarity and subjectivity. So polarity gives us the sentiment of the sentence. The polarity score of a sentence comes between -1 to +1, where negative scores indicate negative sentiments and positive indicate positive sentiments. Another thing which it has is subjectivity. So subjectivity tells us uh, about whether the sentence has more of a personal opinion or it has more factual information. The subjectivity ranges from 0 to 1, but for our model, for our research, subjectivity didn't have much impact on it, so we only chose to give importance to the polarity. Next model is Vedar. So Vedar is again very famous these days. This is because it also supports sentiment analysis of emoticons and other symbols and slang. The sum of a sentence again in Vedar comes in the range from -1 to -1, where negative numbers indicate negative sentiments and positive indicate positive sentiments. So it again has weight associated to the words and is a lexicon based approach. Now the methodology is how we went about the process and the research and the outcomes. So the first thing which we did was we took a data set. The data set which we chose was IMDb reviews. It had about 50,000 reviews. Then we pre-processed the data. So pre-processing involved steps to stem the data. Stemming the words basically means bring it back to their root form, which makes it easier for the models to give their weights to. Then it involves in correcting the spelling or removing of stop words, etc. Next was we found out the score of three each three individual models. So not aggregating them right now, but trying to analyze their accuracy individually. So we use the pre-processed, we use the data on on Affin, TextBlock, and Vadar. Now we compare their accuracies. After this, we normalize the score. So now the normalized score of each model should be between 0 to 1. Then we set a threshold. After that, we did fuzzy aggregation of these three models to find out a new score. So now if the new score is above the threshold, it is positive sentiment. If it is below, it is negative sentiment. After that, we did performance analysis. So basically, we compared the outcomes and accuracies of all the three models and the new model or the score which we were getting after aggregating them. So the first step was again data pre-processing. It involved HTML removal of HTML strips, brackets, noisy text, special characters, stemming the text to root words, removing stop words. So stop words are words which don't give much meaning to the sentence, such as and, or, the, a, etc. Then one of the major steps was normalization. So the range of score which we get in text block and radar are between -1 to +1. So we can simply apply the formula which is on the screen, which is score minus minimum score upon maximum score minus minimum score to normalize them. So now these two will give us a score between 0 to 1 after being normalized. But now affin doesn't have a lower range or a upper range in terms of the aggregated score. So now, what we do know that each word has uh, its weight associated with it in the range of -5 to +5. So we found the aggregated sum, divided it by its the length of the sentence. Now this score is between -5 to +5. Then we can use the formula on the screen to find out the normalized score. So now the normalized score of each three models is between 0 to 1. Then we did fuzzy aggregation. So we used fuzzy aggregation. It was done by taking weighted averages of these three member functions of the scores using the formula which is on the screen. So after using weighted averages, we got uh, the fuzzy scores, and we needed a threshold because we can't classify or we can't find sentiments without a threshold. So we set the threshold to 0.5. So if our new score is above 0.5, it is considered as positive. If it is below, it is considered as negative. So now the results. So when we pass the data through our models individually initially, the accuracy which we got from Affin model was 71.27%, and as we can see on the screen, some of the entries of the data, the scores are not normalized and are varying and are integers. The second model was TextBlock. It gave us an accuracy of 75.434%, and we can see that again the scores are not normalized. TextBlock gave us the most accuracy out of all these three models. The next model was Vadar. So Vadar gave us accuracy of 69.818%, and again we can see the scores are not normalized. Now we normalize the scores. Now we can see that AFM scores, TextBlock scores, and Vadar scores are normalized and are between 0 to 1. These are some of the few examples of the dataset after normalization. Now, after normalization, we wanted to find the weighted averages, and we wanted to use fuzzy aggregation on all three models. So after that, we found out the weights of the new models. So 0.6 was weight for text block, 0.3 for Affin scores, and 0.1 for Veda scores. So after this and finding out the new score and using the threshold of 0.5, we achieved an accuracy of 7.508%, which was more than any of the three models. Here we can see and compare all the three initial models and the ones which we created. So we can see their ranges after being normalized, their fuzzy aggregation weights, and their accuracies. So out of all these three and a new model, the new model which we had gave us more accuracy, the most accuracy of them all. and the weights which were are used after fuzzy aggregation were 0.5 for text block, 0.3 for affin, and 0.1 for VEDAR. So this is the confusion matrix about and position, recall, and F1 score, and we can see it has pretty good scores for the integrated model. So now the future scope. Uh, the future scope is that, first of all, doing this increases the accuracy and robustness. This is because we can leverage the advantages of all three models. We can also customize and fine tune it to the domain which we are applying this model to. So we can change the weights and thresholds so that it can give us better outcome for the domain in which we were trying to fit it in. The dataset which we chose were IMDb dataset, but it can be used for other datasets also. And the last was real time and large scale applications. So it can be used in real life applications to supposedly find out the sentiments towards a product or a company before going public, which could impact its IPO. And it could also be found out to sentiment, find out to find it can also be used to find out people's sentiments about a new policy or a party during elections and other stuff. So these are some of its few exam applications in future scope. Thank you all for being here with me and listening to my presentation. Thank you.